Welcome to the Explainer. Today, we are putting on our detective hats. We're going to crack the case of how automated vulnerability scanners work. The software that's designed to find security flaws before the bad guys do. Think about that for a second. It's a pretty scary thought, right? Well, in the digital world, that's a risk we face constantly. All the software we use every single day can have these hidden broken locks or vulnerabilities, just waiting for someone to find them. But the good news is we have a tool on our side that's built specifically to find these weak spots. And for this explainer, let's just think of it as our own personal cyber detective, the one who systematically checks every single door and window in our digital house. So here's our game plan. We're going to follow our detective through a 5-step process that really breaks down exactly how it hunts for these hidden security flaws. Okay, first things first, for a digital detective, you got to understand the scene of the crime and, the nature of the flaws we're even looking for. So here's the fundamental problem, right? All software is written by people, and, well, people make mistakes. These little mistakes can create hidden flaws. Could be a bug, a bad configuration, or just something someone overlooked. And those become potential entry points for attackers. And that brings us to the first real phase of the investigation, casing the joint. You can't find weaknesses in something if you don't even know what you're looking at. So the detective's number one goal is to map out what's called the attack surface. The easiest way to think about this is like getting a complete blueprint of a building. It shows every single door, window, vent, and access panel, basically any possible way an intruder could try to get in. And to build this map, the scanner kicks off a reconnaissance mission. It scans the whole network to find all the active devices, it checks for any open digital doors or ports, and it identifies every single program that's currently up and running. Okay, so once that initial map is drawn, the detective moves on to something called fingerprinting. And no, it's not about dusting for prints. This is all about getting a positive ID on every piece of software and hardware out there, creating a really detailed list of our persons of interest. Now, how it gets this info is actually pretty cool. Banner grabbing is basically like reading the label on a piece of equipment to see the model number. And service probing is more like asking it a very specific question that only a certain version would know how to answer. Both of these techniques help our detective get a precise ID. And that quote just sums it up perfectly. This whole process, the reconnaissance and the fingerprinting, it is all about creating that super detailed blueprint before you even start looking for tiny cracks in the foundation. All right, so now we have a detailed list of every asset, all our suspects. The next step for our detective is to check their records against a global database of known criminals and their past offenses. This is really the crucial matching phase. The scanner takes its detailed list and just cross-references it against a huge library of documented weaknesses. So for example, if it finds a server running a specific version of a tool like, say, Log4j, it's going to immediately flag it because we know older versions of that tool had a massive, well-known flaw. And the main tool for this background check is a public database called CVE. Honestly, you can just think of it as a universal rap sheet for software bugs. If a weakness has been discovered pretty much anywhere in the world, you can bet it's going to be listed here. But, a good detective doesn't just rely on old records. They need to confirm their suspicions. So it's time to move from doing research to conducting a full-on active investigation. So this is a really crucial point, the difference between just watching from a distance and actually getting hands-on. Passive scanning is like surveillance. You're just observing what's happening. Active scanning, though, that's like an interrogation. The detective actually sends specially crafted data to see if the system cracks under pressure, which confirms that the vulnerability isn't just there, but it's actually exploitable. Okay, the investigation is complete. Our detective has mapped the scene, identified all the suspects, checked their records, and confirmed their weaknesses. Now it's time to file a clear, actionable report for the security team. Let's be honest, a giant list of 1,000 potential flaws isn't very helpful, is it? The real value here is prioritization. The detective's report has to clearly show which broken locks are on the front door versus which ones are on, say, a shed in the backyard. And this prioritization is actually done using a universal standard called the Common Vulnerability Scoring System, or CVSS. What it does is it assigns every single vulnerability a score from 0 to 10, and that score is based on things like how easy it is to exploit and what kind of damage it could potentially cause. This scoring system is a game changer because it lets a security team instantly see which fires they need to put out first. They can focus all their energy on the critical vulnerabilities, the ones that pose the most immediate and serious danger, before they even think about moving on to anything else. So, just to recap the whole operation, our digital detective really relies on these three key things working together perfectly. You've got the scan engine doing all the legwork, the vulnerability database providing all the intelligence, and the reporting module that makes sense of it all. This systematic process is, without a doubt, our best first line of defense in what is an incredibly complex digital world. But it does leave us with one final and pretty crucial question. In this constant cat and mouse game of cybersecurity, are our automated detectives really enough to keep up with criminals who are always looking for that next unknown flaw?